Hello everyone. Now that we have already studied about tangents to a circle, we are in a good position to solve all the questions of practice set 3.1. So in this video, we are going to solve all the 4 questions of practice set 3.1. Pause the video and write down the first question. According to the first question, there is a circle given which has a center C. It is also given that the radius of the circle is 6 centimeter. So any point from the center to the boundary is going to be 6 centimeter, and there is a tangent of the line AB. Now we have to find a few things. First is angle CAB. We have to find the distance of AB from the point C. We have to find the distance of between the points B and C, and also we have to measure the angle ABC. So these are the 4 things that we have to find. Let's quickly start solving them. Now in order to solve this question, the first thing that I need to do is join the points C with A and B with C. This is the first thing that we have to do. And we will write down what is given to me and what are the few things that I need to find, which we are very good to write. Now let's quickly start. The first is angle CAB. As soon as I join the point C and A, I see that this is the radius, and any point from the center is perpendicular to the tangent. So any radius is going to be perpendicular to the tangent. A point from the center to the tangent will always be 90 degree. Hence the angle CAB is 90 degree. The reason being tangent theorem directly. From there I move ahead to find the distance CA. Now if you see in the figure, CA is nothing but the radius of the circle, and the radius is given to me as 6 centimeter. So CA directly becomes 6 centimeter. Now in the third part I have to find BC. To find BC, I would want you to focus on the triangle that is being formed here. Triangle ABC that is being formed. One of the angle is 90 degree. You know the side AC. You know the side AB also, because it is given that AB is 6 centimeter. So you know the two sides, the height and the base. You have to find the hypotenuse. What you can do is you can apply the Pythagoras theorem. So you apply the Pythagoras theorem and you get that BC square is nothing but 72. BC is the same as CB. So when you find the square root of this, you are going to get the answer as 6 root 2 centimeters. This was the third part of the question. Now we are going to the fourth part, which will force you to think a little bit. In triangle ABC, the two sides AB and AC are equal, which means it is an isosceles triangle. Keep on referring to your diagram in the notebook. If it is an isosceles triangle, you know that the two angles are going to be equal. Which two angles? Let me get back to the figure. Here AC and AB are equal, so this angle C and this angle B are going to be equal. Now one of the angle is 90 degree. How do you divide the remaining 90 degree into two parts? They have to be 45 each, only then the sum will be 180 degree. So we are going to use this concept over here. So we write that sum of all the angles is 180 degree, because the sum of all the angles of triangle is 180. We put back the value. Since ACB is equal to ABC, I am writing ABC 2 times because these two are the same. Then you take the 90 on the other side. This is twice ABC. You divide it by 90, you get 45. So angle ABC is nothing but 45 degree. This was the first question. Since you are finding many parts to it, make sure you write all of them down as the answer given over here. Moving to question number 2 again. Now my recommendation is, if you have the textbook, you don't need to write the entire question. You can just write practice set 3.1. You can write down the question number and start with the solution. Okay, so pause the video, write down the question if needed. The question says that I have a circle and the center of the circle is O. There is a point R outside the circle, and from R I am drawing two tangents, RM and RN. They are tangents because they will touch the circle only at one point. OR is given to me as 10 centimeter. The radius is also given to me as 5 centimeter. I have to find three things. I have to find the length of each tangent, which is I have to find the length of this tangent Rm and the length of this tangent Rn. I have to find angle MRO. So MRO, this is what I need to find. I also need to find MRN. Okay, so write down the question. Moving ahead with the solution now. In order to proceed, what I will have to do is I will have to join the 2 points O to M and O to N. Now as soon as you join this, you know that perpendicular from the any line from the center is going to be perpendicular to the tangent by the tangent theorem. So these two angles automatically come to be 90 degree each. The radius is given to me as 5 centimeter. Now the point OM, this line is nothing but the radius. So they become 5 each. And here in this triangle I have this longer side, which is the hypotenuse, as 10 centimeter. This is the information which is given to me, and these are the 3 things I need to find. Now let's move ahead with the solution. The solution is very simple. Clearly you can see that this is a right angle triangle. You have one side, you know the hypotenuse, you need to find the remaining side. You will directly apply the Pythagoras theorem. Using the Pythagoras theorem, what I see is, I find the value, substitute all of them. This is 100, this is 5 square 25, this goes to the other side, becomes minus. So MR square is nothing but 75. You can pause the video and write this down. The square root of 75 is going to give me 5√3 centimeter. MR is 5 centimeter. You also know the another theorem, the tangent segment theorem, that if you are drawing 2 tangents from one point, the length of both the tangents will be the same. So Rm will be equal to Rn. I got Rm as 5√3, which means Rn is also nothing but 5√3 centimeters directly. This is what I have found for both the lengths of the tangent. Now I go to find the angle MRO. To do this question, what you need to do is apply the concept of trigonometry. What I have done is, in my figure, if you can see, I will take you back to the figure. I have assumed this angle to be theta. Okay, if this angle is theta, this side becomes the opposite side, this side becomes the hypotenuse. So you have the opposite side, you have the hypotenuse. You can use the formula for sine, if you remember, which is opposite side by hypotenuse. So I use the formula for sine over here, put back the values, this gives me 5/10, which is nothing but half. Now if you go back to the table, sine half kahan pe hota hai? When the angle is 30 degree, which means the theta that I have taken has to be nothing but 30 degree. So this way I have found angle MRO. Now I have to find the bigger angle MRN in the figure. For that, again, if I go to my diagram, I can see there are 2 triangles. If you go and visit the picture in the notebook, keep on seeing that. There are 2 triangles, OMR and ONR. And in both of them, the radius is equal, 5 centimeters each. OR is the common side and one angle is the same, which is 90 degree. If you remember how we proved the congruency of triangles, then by using right angle, hypotenuse and side concept, okay, RHS. As soon as I use RHS, OMR is congruent to ONR. अब जैसे ही 2 ट्राइंगल्स इक्वल होंगे, उनके करस्पॉन्डिंग साइड्स और करस्पॉन्डिंग एंगल्स इक्वल हो जाएंगे. सो बाय CACT, MRO is equal to NRO. If I take you to the diagram now from here, taking back to the diagram from here, MRO, this angle which I have written theta, is equal to NRO, which is again theta. So both of them are same. ये मैंने 30 डिग्री फाइंड किया था, which means this also has to be 30. अगर दोनों 30 है, then this bigger angle MRN is how much? It is 30 plus 30, which is 60. So I take you back to the solution now. Here is what I have found. As soon as they are congruent, the 2 angles will be added up. It will give you 60 degrees, and hence the length of the 2 tangents are found. Angle MRO has been found and MRN has been found. This is how we have solved question number 2 as well. Now let's move to question number 3. Again, pause if you need to write the question, or you can write from the textbook also. The question says that again you have two tangents from the point R. You have to prove that OR, this line OR, is going to bisect this bigger angle MRN, and it will bisect the bigger angle MON. Bisect का मतलब है it is dividing this into two equal halves. If it is dividing it into two equal halves, if I prove that this smaller angle MRO is equal to this angle NRO, then I can say this bigger angle is bisected. And if you recall, this was what we just did in question number 2. So we are going to repeat the same thing here, and this time for both the angles. So what we are going to do is we are going to prove the congruency of the triangle. So let's write down what is given. What is it that I need to prove? The to prove has changed because I am going to show this that the two angles are equal. अगर ये equal है मतलब इस line ने इसको bisect किया है. Okay? The proof is similar. I take both the triangles. OM is equal to ON. Why are they equal? Because both of them are radius of the same circle. Radius का plural होता है radii. OR is common to both the sides, so they have to be equal. And the angle is 90 degree in both the cases because of the tangent theorem. Again, by using RHS congruency, I can say that the two triangles are equal. As soon as the two triangles are equal or congruent, their corresponding angles are equal. So by CACT, I write these two angles are equal. And this is what I had to prove. So I can write OR bisects my two angles MRN and MON. Amazing. With this, we are coming to the last question of the practice set 3.1. A very small question which says that what is the distance between two parallel tangents of a circle having a radius of 4.5 centimeter? So the question says I have a circle and I have two parallel tangents which I have drawn here. You see the one on top and the one on bottom. These are two parallel tangents. The radius of the circle is 4.5. Now if you have solved example number 2 in the previous objective, you remember we proved that अगर दोनों tangents parallel हैं तो उनके बीच का जो line होता है वो diameter होता है, which means this line that I am drawing PQ is nothing but the diameter, and diameter is nothing but the double of radius, which means अगर आपका radius 4.5 है तो diameter आपका बन गया 4.5 into 2 which is 9, and the distance between the two parallel tangents is then 9 centimeter. So this is what we have written over here, that the distance between two parallel tangents is the diameter of the circle, and hence the diameter is 2 times the radius which is 9. With this we come to the end of all the questions of practice set 3.1. I hope you had a clear understanding. Thank you so much. Have a nice day.